Good morning, everyone. So myself, Parmeshwar Prasad, and along with me, Rahul Vishwakarma. So let's talk about the blockchain in the storage. So we'll talk more on this, like how the blockchain can be used in the storage, how this technology is going to change the storage world, and different use cases. So SNIA TWG, it's a SNIA blockchain technical working group. So I'm co-chair of this committee, and this committee was started sometime in April 2020, and from then we are to the place where we are in the process of creating a spec where we can design the blockchain and the use case of blockchain in the storage. We can design the interoperability of the blockchains and different other so some of the goal what we have in our technical working groups, it has been listed here, so we will be achieving that. So before going into the deep, let's understand what is the blockchain. So I will start this with the block, because the block is the building block of the blockchain. You can see in this diagram I have a block which is number 1. Then I have nonce. Then we have the data field and the hash. So hash is the integrity of any of the data available. So you will be aware of that. Okay, if I have some data and the data hash, if I calculate later on, so hash will be the same. So it will not change. So that makes the uniqueness of the blockchain. Means where we are checking the integrity of the data or the block or a piece of information by the hash. So a block can contain the block number, the nonce, the data, and the hash. And when we join these blocks, maybe one by one, and when we create a bigger database, it becomes a blockchain. So blockchain has the different features, like it's a programmable. I can execute some piece of code when we are going to add some block in the blockchain. It's a secure because changing the entry in the blockchain is almost impossible. It's a distributed database. So a piece of the information or the same piece of the information will be shared between the different parties. Those parties, sometimes we call it as a peer, sometimes we call it as a node, sometimes we call it as an account. So interchangeably, we talk like they are the peer, node, or the account. So all are the same. Now let's understand what is the blockchain. If you see here, we have a block 1, then the block 2, block 3, and block 4. And all the blocks has some data in it. Say in the block 1, we have the test data in block 1. In block 2, we have test data in block 2. Same way in the block 3 and block 4. So this data, which is available in the blocks, different blocks, and the associated hashes. Just notice on this particular hash what is available in the block 1. If you see in the block 2, the same hash being used as a previous hash. It means I can say that, okay, what the data integrity was in the block, in the previous block. I may not be able to know the data, but I will know that, okay, what the integrity of the data will be by reading the hash or by knowing the hash. And same way once it proceeds. So block 1 hash will be available in the block 2. Block 2 hash will be available in block 3, and subsequently it will be keep going. So what is the beauty of this particular design? We are associating the is blocked by the hashes. So we are saying that integrity of the data is always maintained, whether it's keep adding the data, or once we are reading the database, or once we are adding. So we say that, okay, we are maintaining the integrity of the data, and it's a chain of the record. We are keep adding the record in the blockchain. And one thing is very much clear here, like once we say that, okay, the hash, the previous block hash is kept in the current block, it means I cannot go and change the data. If someone says that, is it possible to delete the data from the blockchain? So answer is no. Is it possible that can I go and alter the information from the blockchain? Answer is no. Can I modify the data? Again, the answer is no. So you can think this is a data where we are keep adding the data on data in the form of the block, but we are not going to change it ever. So what makes a blockchain? Bare minimum, we need to have the hash, we need to have the consensus protocol. When it comes like consensus protocols means how a block can be added in the blockchain, how anyone or the number of peers can decide like, okay, this block I need to add, this particular information I need to add in the blockchain. We have currently a lot of cryptographic algorithms such as SHA-256, Whirlpool, right, EMD, and SHA-256 is very popular. Even the Bitcoin is using the SHA-256 cryptographic hash function. And some places we have the Dagger Hashimoto and other cryptographic algorithms. Merkle tree plays an important role in the blockchain. Say I have a piece of the information, maybe like in the form of 10 blocks, 10 different blocks. And probably I wanted to say that, okay, well, my 10 blocks is going to play a role of the single block. So how we can deal this situation? So the situation we can deal by having the each individual hash calculated at once in the form of tree. Say I am having the root, then the different leaves, then subsequent leaves. At the bottom, say I have the data, then I calculated the hash of the data. Again, in the second layer, I will calculate hash of the hash. So ultimately, I'll have only one hash, which will be the root hash. In that way, we create a Merkle tree. So this is important because the database in the blockchain, we cannot always say that, okay, keep adding the information in the blockchain. In that scenario, it becomes a bulky. To avoid the bulkiness of the blockchain, we use the Merkle tree in the blockchain. There are a lot of consensus protocol in the blockchain. Some of them are like proof of work, proof of space, proof of stake, proof of capacity. And nowadays, people started giving a lot of names with starting proof, like proof of identity, proof of time elapsed, proof of maybe XYZ. So proof of work is like I am proving that, okay, I have done some work and the work is valid. Based on the validity of my work, someone can trust me that, okay, I have done the work. Same way we have the proof of space. If someone says that, okay, I hold some space to do some of the work, this space can be in the form of the memory, or this space can be in the storage device also. Then we have the proof of space, proof of storage, and proof of capacity. Sometimes we interchange all this word. We say that, okay, this is proof of space, and sometimes we say that, okay, this is proof of capacity. So we interchange and use for the same purpose. So now come in the deep, why we need to have the blockchain in the storage, why storage needs a blockchain, or what all the basic fundamentals which are defining the blockchain in the storage. So let's start all these things by having the proof of space and proof of capacity understanding. Why do we need to have the proof of space and proof of capacity? What kind of beauty it holds? It holds the beauty like every proof I can say by either having a storage or by saying that, okay, I have some capacity, such as like a proof of space or the proof of capacity. So I say that, okay, I have a particular space or maybe RAM size, what I can use for processing something. A person can say that, okay, I have some space for sending a mail. I have some space for doing some operation or maybe some database operation. So that's where the proof of space and proof of capacity plays an important role. In my previous slide, I was talking about the proof of work. So the proof of work is like I need to solve a very complex problem. When I need to solve a very complex problem, then I am consuming a lot of CPUs, a lot of memory, a lot of bandwidth, a lot of network. Just think whether that's a good approach or not. Let's think about the environment. Say I am doing some work just to solve some of the puzzle, to do some complex mathematical operation. I have run the CPU thousands of times to achieve to some conclusion that this is what the result it is. Later on, someone will say that, okay, this result is perfect or fine. But once we do that, we are going to consume a lot of electricity, lot of CPU power, lot of memory, and lot of network. This is not a environment friendly operation. So we need to have some environment friendly operation, and that should be based on some other kind of proof. That other kind of proof is proof of space and proof of capacity and proof of storage. In this alternative, we say that, okay, we hold some storage or the capacity or the space. And a validator can say that, okay, I am having some valid storage. Maybe I am the correct entity, and that will be used in the consensus. Once that is being used, then we say that, okay, a valid peer is saying that, okay, he had the storage and his transaction has to be added in the blockchain. Proof of space is also being used in the cloud storage, in which the peer contributor contributes their free disk space and gets service by the network. So StoreJ is one good company who are working on the same principle. So they provide the storage solution on the cloud based on the proof of storage. Proof of capacity. So the proof of capacity, when I was telling in my last slide, it's like, okay, I have my free capacity available. Probably that capacity I can use for proofing something. And this is basically based on the Sahiwal 256 cryptographic algorithm. And this is ASIC resistance. ASIC resistance means I'm going to have my IO, I'm going to do some memory transaction and all. And I will be doing lot of writing, lot of uh, IO writing, lot of storage writing. And this is one-time process. It doesn't require you to do continuous hashing. It's like I have a data, I did one time of the hashing, and I have my results. And it's always economically is environment friendly and economical approach. If you see in this diagram here, so mk minus 1 and mk, all these are the block of the data, and abc are the different parameters, and this abc goes through the complex XOR and operations, and they are associated with different weights. So in the normal round, I take the data in such a way that It depends on the older and the current data block. When it comes to the final round, so it is a set of three identical calculation where I do the same operation 3 times. Then I get Sehwal 256 cryptographic output. And people are telling that the Sehwal 256 is the one of the greatest candidate for the SHA-3 series of the algorithm. The working principle of proof of space. A proof of space is a piece of data that a prover sends to verify to prove that prover has reserved a certain amount of space. Say, I have a cloud storage based on the proof of space. Maybe like if 10 nodes are participating in the network, now a network or some peer in the network can say, I have some free space reserved. Now, maybe for the next transaction, that free space can be used. And who is the validator? The validator can say, okay, you have the valid free space, and probably next time you will be served. For practicality, the verification process need to be efficient, namely consume a small amount of space and time. Like I have told in my last slides, like proof of space and proof of capacity, they are the eco-friendly operations. They don't need much power. So when we have the proof of capacity or this space deployed, typically they should not use much power. So proof of space can be implemented by hard to pedal graph. And let's understand the proof of capacity in this. So we will be creating the nonces here. If you can see here, this is a big nonce here. It's of the size of 8192, all the hashes. What we will have in that, so we will have the 8 byte of the nonce here, then 8 bytes of the account ID and the hash. It goes through a Sehwal 256 algorithm. Then later on, it produces the result. So this can be also done in a form that I have a sub of this nonces. Means I can divide it in the two part. Portion of initial is scoop 0, scoop 1, and to half of the scoop. Then from half of the scoop to the 4095 of the scoop. In that way, we can divide it. In further slides, you can see one more beauty here. Like all of these nonces are the mirrored, if you see. Hash 0 is exactly same of the hash last, and the scoop last here is exactly same here. So if you see, we are mirroring it. And the data mirrored here is used for the proof of capacity. And this can be subdivided from 0 to 2047 in one group and 2048 to 4095 another group. So that is also possible. To shuffle the data into correct place, we take the second hash of the scoop in the row in the low range and the swap it with the second hash in the mirror scoop fund in the high range. Why do we need to have decentralization? So decentralization helps in a lot of things. Like it provides architectural decentralization, it provides a political decentralization and logical. When we decentralize, probably we can use the technology in the best manner. Some of the advantages and disadvantages I have listed here, such as fault tolerance and the attack resistance, collision resistance, and some disadvantages like duplication of work. You have seen in the proof of capacity in my previous slide. I have mentioned that, okay, it is mirrored. When we are mirroring the same thing, it means we are wasting some data. Probably that's a duplication of work, and maybe like, okay, someone can say that that's not a good approach. And this also holds like a lot of decision maker we have. When we have a lot of decision makers, say like I have 10 or 20 or 50 peers, probably I need to depend on some of them or maybe all of them to come to a conclusion that a particular block need to be added, or it's like okay, valid block or something. So probably that's a kind of disadvantage had, and the speed of action. When we have many people to take the decision, probably we have to have the consensus from the everyone, and that reduces the speed. Interoperability. So this is a very important thing. Why? We have the different blockchains currently already running. Say we have the Bitcoin, we have Ripple, we have Ethereum, we have Hyperledger. They are built on the different proof of things, such as like Bitcoin is based on the proof of work, and all other are slowly they are moving to proof of space or proof of capacity, and they are being used in two different use cases. Say like I created a network, maybe Hyperledger has created a network, Ripple has created another network, and they have deployed. Now there will be chances that sometime I need to go and talk between these two networks. So if we don't have the proper protocols for the interoperability, we may not be able to talk to different networks. So in SNIA, we are also working on this aspect also, that how a blockchain can talk to another blockchain. So interoperability is one of our major target where we wanted to work, and probably we wanted to bring the protocol where all of other participating companies can get help from this. So what the need of that is, and how the design has to be. So problem like we have lot of protocols designed. Maybe like the Ethereum has the different protocols, and the Ripple has the different protocols, and they are having their own mechanism to exchange the data. They have their own mechanism to do certain operation. They have their own mechanism for the consensus. They have their own mechanism for the smart contract. So how two different blockchains can talk? So definitely we need to have a protocol where these blockchains can talk to each other. And when we are designing such system, it has to be independent of the consensus. It has to be independent of the sovereignty, whether my blockchain is public, permission, or the private. I should be able to talk to other blockchain. It should not be case like, okay, only public blockchain can talk to public blockchain. Only permission can talk to permission. It should be combination of all kind of blockchain should be able to talk to any kind of blockchain. And it should support a unique asset transfer across the blockchain. Say I have the Bitcoin in my Bitcoin network, and in the Ripple I have the Ripple coin, and Ether we have in the Ethereum. How Bitcoin, Ripple, and Ethereum coins can be transferred to different blockchain network. We need to think about that. And it should be scalable. It's not like, okay, we are providing interoperability only for the coin transfer or only for the smart contract. No, it should be a scalable approach. We should be having the mechanism where we are able to scale to a larger deployment along with catering the small requirement, and its performance and security that has to be very high. The performance has to be very high in such a way that, okay, if a blockchain is performing slower and other blockchain is performing higher, probably whatever the interoperability protocol we have, that should solve the problem of the performance and security along with that. There should not be any mechanism where I'm going to say that, okay, my blockchain can be hacked or it can be forked. That's also bad for the blockchain. Okay, so I talk about the uh, interoperability. So let's understand like what all networks we have who are providing very good support in this field. So Cosmos network is one of the very good network where they are saying that they are interoperable. How they are? Just see in this diagram. So I have hub 1, hub 2, and different zones. And we have Ethereum and Bitcoin. You think these zones are the different blockchains? Say like Ethereum, Bitcoin, Ripple, Hyperledger, or some other blockchain. So they are connected with the hub. You understand, like one kind of blockchain is kind of a network. How we connect one network to another network? By using the hub. So how they have achieved it? So they have the SDK to do this job. So SDK is developed in the Go and C++ languages. And along with that, they have the IBC, Inter-Blockchain Communication Protocol. And they have redesigned the Byzantine fault tolerance, and they named it Tendermint BFT engine. So along with the IBC and SDK and the BFT, they are saying, okay, we can communicate to other blockchain with the help of the hub. Anything can be transferred from Bitcoin to hub, then from hub to Ethereum. Same way, from Ethereum, it comes to hub 1, it goes to hub 2, then it goes to this blockchain. So that's how they can transfer. And they have the concept of the peg also, link blockchains with the fast finality and probabilistic finality. So when I was going through in the details, like how it is working, so I understood that they lock one kind of the blockchain and then they transfer the asset. So like I have the Bitcoin, one Bitcoin network here. Probably if I wanted to transfer all the Bitcoins from this network to Ethereum, what I will do, I'll go and log the Bitcoin network. Then whatever the tokens or coins I had, with the help of Hub, I will transfer it to Ethereum. That's how we can do it. Hyperledger interoperability. So Hyperledger also has some interoperability work being done. So this just started recently. So what they say, they will have 3 different kind of the sub blockchain. The names of that sub blockchains are like the broker blockchain, subscriber blockchain, and publisher. So in the middle of all 3 blockchains, they will run 2 different smart contracts. So that will be doing the job of that will be responsible for the interoperability. And more details you can get from here. Still their work is in progress, so a lot of work they are going to do in this particular fiscal year. So probably this is an interesting space where we can get a lot of information. So what SNIA is doing and what the SNIA proposal is and how we are working in the SNIA and probably what is our proposal. So we are proposing a solution which can solve the scalability. So where the transaction cost is very less, maybe zero, which is very good in the interoperability, and adoptions issues are not there. Probably adoptions are very fast in that. Such use cases where we see that, okay, blockchain is being used for the right holding, how that right can be transferred. So we are working in those cases also. So if you see Bitcoin blockchain, Ethereum blockchain, and few other blockchains. So what the special features they have, they are based on the single blockchain. Is all the data in the blockchain will be keep adding. So after some time it will become bulky. Say I'm adding block 1, block 2, block 3, block 4, and maybe block thousands or block millions. So after the block millions, it will become like, okay, I have some 300 GB of the blockchain peer node. So where I'm going to store it? Then I need to purchase a bigger server or the more storage. So just think like whether it's a physical, whether it's a feasible or not. Is it a very good solution or not? So in my opinion, I will say no. This is not a good solution. We need to have the multiple blockchains based on the need, based on the persons, based on the task. And I should have the flexibility to have the smaller blockchains. So in my opinion, single blockchain is not a solution. What is the solution? Multiple blockchain. We need to have multiple chain whenever it is possible. Just talk about the use case in the bank. Say, my bank has issued me 2 credit cards, and similar to me, there will be many such people in the bank who are the customer of the bank. So can I do in such a way that okay, one of my card is being maintained by one blockchain, second card is being maintained by the second blockchain. Same way, other customer will have a different blockchain. In that way, what we can achieve, we will have the multiple blockchains deployed in a system, which are very much flexible. We can create anytime and we can destroy anytime. So it can be implemented at the level of the public blockchain and the private blockchain. And it will be, in my opinion, it will be very efficient. So this gives me one pictorial representation. Say there is one entity one, then entity two, and the observer. And entity one has a different chain here. See, the chains are in different color, green color, then this the blue color and the gray color. Same entity two has only two blockchain. An observer is able to see all the possible blockchain. So if you see here, I'm not appending all the data in the single blockchain. I am keep adding all the data. I'm having my data in the different blockchains, and I can give a different role to all people. So people can be the observers, say like the bank manager, or the maybe like a CEO or the upper higher management. They can have the better visibility on all the blockchain. So here it is the SNIA Technical Working Group chain proposal, where we have a block of data here, and I have the private and public key and the signature. By using the public key, I can sign the data. And the beauty of this blockchain is private key will be used in the next block to sign in. So I need not to remember the private key along with me. So this is the biggest disadvantage what the current blockchain has. Like I need to always remember the private key so that I can work with my blockchain. By this approach, the problem is solved, and we are going to create a foolproof mechanism where my integrity of my chain is always kept. It's unbreakable. I need not to have the consensus. Say, like I have the IoT devices. Why I need to have a consensus mechanism means that's a very power consuming and tedious job. I need to talk to everyone. We need to have a mechanism where we can trust. Probably we need not to have a mechanism where we go and say that, okay, I need to have a consensus mechanism, and probably which is going to take more power, more CPU cycle, and more complex. We don't need that. It can be deployed, but it will be always case to case basis. So what I was telling that any chain represents a special record of a statement of a single entity. Consensus required to add a new record to your own book, where the record is signed with the personal private key. Transition between the multiple entities will use data from chains from all the entities. So like I told earlier, we do not to remember the private key of my account. What I need to have, probably we need to think about the integrity of the chain. When one private key is lost, probably next for the next transition, I can create another blockchain. In that way, what I can do, probably I am keep generating the public and private key pairs and keep creating the block. In that way, I need not to remember the key of the account or the peer. We need to focus more on the preventing the chain rather than preventing the account. Chain integrity is more important. So we need to have a mechanism like who has created the block, whether the private key is there or not, public key is there or not. If we embed all those things, a lot of problem will be solved. It should not be like, okay, some vendor has given me a mechanism and I need to just follow that. It should not be a vendor specific. So what is the solution for that? We need to open source. So we need to open source some of the component of the blockchain, whether so that my adoption should increase. Once the open source is there, probably we'll get a lot of good ideas to where we can work. So in SNIA, once our spec is ready, we are going to create some of the open source component. Probably all other companies or the organization can use that. What are we assuming? We don't need traditional consensus. We don't need a single chain. We need multiple chains. We don't have to worry about protection of the personal private key. We need to worry about the protection of the chain. We need to protect the chain. We need to accommodate complexity of the real world. If you see currently, all the blockchains has been designed for a specific case. We need to have the blockchain which is solving the real use cases of the real life, probably which can cater a lot of requirement. We need to open source. So if you see here, this is the block of the information where our proposal lies. We have the different distributed ledger here from the ledger 0, ledger 1, ledger n. Then the blockchain service here, and the service goes to service 1 and service n. In that, we have the smart contract and the authentication mechanism and different APIs. So these are the software layers here. What we wanted to change more, probably we wanted to push some of the blockchain component in the firmware. Then it goes into security. And probably here we can have the private and public key for the blockchain. So we need to create a system where a lot of blockchain can be used, can use it, and probably when they are using proof of space or proof of storage, probably this particular layer can benefit all of the blockchain. That's all I have, and thank you so much for listening it. And you can come back and join the SNIA membership. You can come and join here, and you can get some link here. And probably you can reach out to me if you have questions. So you can reach out to me at parmeshwar_prasad@dell.com. Thank you. Thank you so much.